Hey everyone, and welcome back to Knowledge on Ears. And in today's video, we are looking at a pretty cool experiment with ultrasonic sensors. So right here we have an ultrasonic sensor, and we'll take a better look at this later on in the video, but there are 4 pins that connect directly to this Arduino board. And over here on our laptop, we have our Arduino program running in the Arduino IDE. But what even is this experiment, this program that we're doing? Well, basically, as we learn later on in this video, ultrasonic sensors are used very commonly to measure distances. So what we're going to do is we're going to use this object, this notebook, as our object that we're measuring. And in our serial monitor, it's giving us a distance of measurement, and we're going to confirm that distance, we're going to confirm the accuracy with a ruler. So let's start. So we put our object right here at 0 centimeters, and the measurement is around 20 centimeters with this ruler. And in our serial monitor, it also says like 19.83 centimeters, so it's pretty close to 20. So the accuracy is great. Now let's move to a closer length. Let's move to around 15 centimeters. Right there. We put it at 0. It says the measurement is 14.27, so that's pretty close to 15 as well. Now, if we move a little bit farther away, so let's say we move to 23 centimeters. It says in the IDE that it's 22.38, so that's pretty close to 23. So you can see that our ultrasonic sensor has a pretty good accuracy compared to our ruler, so it works pretty well. Now let's dive into how it actually works. So now, let's dive straight into what ultrasonic sensors really are and how they work. So basically, ultrasonic sensors are devices that measure the distance from the sensor to the object. And they do this by using ultrasonic waves. And these waves are very special because they don't go through the object, but instead they bounce off the object. And that's very important for the ultrasonic sensor because it helps us determine the distance from the sensor to the object, and we'll get into this very soon. So this specific sensor is called the HC-SR04 sensor, and it's used very commonly. You can see it very often for stuff like Arduino and other microcontrollers and microprocessors. But how does the ultrasonic sensor really work? So let's take a look at this right here. There is a lot of different circuitry and stuff like that, but the most important part are these 4 pins: ground, echo, trig, and VCC. And we already know VCC is where we get the power from, and ground is ground. But echo and trig are 2 very important pins. Trig actually stands for trigger, by the way. So over here we have 2 different cylinder parts protruding from the sensor. These do a lot of the main processes, and they are transducers. So if you don't already know, transducers are devices that convert energy from one form into another. So in this case, these transducers convert either mechanical energy into electrical or electrical into mechanical. And there are 2 different transducers. One of them is a transmitting transducer, TX, and one of them is a receiving transducer, RX. And basically, the transmitting one transmits ultrasonic waves to the object, and the receiving one receives the waves that bounce off. And the special thing about these transducers is that they have a special crystal in them called a piezoelectric crystal, or piezoelectric, depending on how you pronounce it. So what piezoelectric crystals are is that they are crystals that basically either turn electrical energy into mechanical vibration or mechanical vibration into electrical energy. So let's say you apply an electric current to a piezoelectric crystal, often that creates a mechanical vibration, and we'll get back to that. So the transmitter is corresponding to the trig pin, and the receiver is corresponding to the echo pin. So let's take a look at an example to see and actually understand how this works. Let's say this is connected to an Arduino board, and we're running this program with the Arduino. When the Arduino actually sends a signal of a high signal for 10 microseconds to the trig pin, the trigger pin, that is a very important signal because that tells the transmitter to start transmitting ultrasonic waves. So if you send that signal for 10 microseconds, it starts transmitting the ultrasonic waves. How? Because the current that passes into the piezoelectric crystal inside the transmitter starts generating this mechanical vibration, and then that mechanical vibration turns into ultrasonic waves. So the ultrasonic waves hit the object, and then they bounce off and go back into this one now. So it's entering the receiver. Now what happens is that this ultrasonic wave is taken, and then it hits the piezoelectric crystal, then it turns it into an electric current. So how does the echo pin come into this? Well, when the transmitter starts transmitting ultrasonic waves, that indicates the echo pin to turn high. And when it turns high, this whole process happens, the wave comes, it bounces, and it enters the receiver. And when it enters the receiver, that tells the echo pin to go back to low. And the time the echo pin is high for represents the time it took for the wave to hit the object and come back. And now, using that time, the Arduino can calculate what the distance is between the sensor and the object. So we do that using a simple formula. We already know distance is speed times time. But we also have to divide it by 2 to actually figure, because the wave is going 2 ways. It's going there and it's coming back. So we divide it by 2. And we take the speed of the ultrasonic wave, we take that specific speed, we take the time that the echo pin figured out because it stayed high, and then we have to figure out that distance. And it's very simple. And these parts come together to play a bigger role and to do this and to figure out the distance. So I hope this made a lot of sense. Thank you so much for listening, and bye!